How many lines per centimeter does a diffraction grating have if the third order maximum occurs at a 23.0 degree angle for 630 nanometer light? All right, that's a mouthful of some crazy stuff. So let me draw the picture of what this problem is actually really talking about here. So a picture of what this thing's actually talking about is it's a basic experiment where you've got light that's shining through two slits. So most of the light's being blocked, but some of it can escape through these slits that you see here. And as that light escapes, it travels forward and it's projected onto a screen. And what you end up seeing is quite interesting. It actually ends up that if I draw this light in the middle, then what waves tend to do is spread out. So I'm going to show one particular path they can take, and that's both of them traveling kind of toward the middle of where these two slits were. And if that's the case, then both waves travel the same amount, and you kind of get the same part of each wave. You got like the bottom of this wave and the bottom of that wave, or the top of this and the top of that. But either way, you get a constructive interference. So what we get at this location is a bright spot. So I'm going to draw that with an open circle. That shows that it's bright at that location. And there's another location where the same thing could happen. Let me draw it with a different color. So this time I found a new location where both of them are traveling slightly up, and this drawing isn't spot on, but hopefully you can get the idea. The wave that's traveling from the bottom here has a slightly longer distance to go than the wave that's above it. But if we do it at like the perfect location, so that this one has to do one more full wave than the one up here because it has to travel a little bit farther, well then you can still end up with the bottom of both waves at the same place and you get another bright spot. It's just maybe this one waved 3 times and this top one only waved twice, but you still get bottom on bottom, which gives you constructive interference, so you get another bright spot. So if I draw this whole pattern out, I'm not going to show all the waves that make this happen, but basically you end up with a bunch of bright spots and a bunch of dark spots on the screen when you do this experiment. The bright is where the waves constructively interfere. You either get a top and a top or a bottom and a bottom, however you want to think about it. And the dark is where they destructively interfere. So you get the top of one wave and the bottom of the other. And you get this pattern all along it. And in physics, it's important for us to be able to figure out where the bright and dark spots are going to occur. And that's what this problem is talking about, is we want to figure out exactly what angle that's happening at. By the way, sometimes people use these little hump things to show how intense the light is at that particular location. So for example, here, it's very bright, and then it gets darker, 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 totally black, and then brighter, brighter, brighter. But notice it's not quite as bright here because the light's not going quite as straight, so not as many waves spread out that much. But you get this little mountain-looking thing, so just so you guys know what that is if you ever see that on a problem. But let me get to the problem at hand and solve that for you. So if you look on your formula sheet for this one, under optics, you should see d sine theta equals m lambda. And this is going to be our go-to formula for this, but it probably looks pretty weird. So let me explain what each of the individual variables mean. So d represents the slit separation, which is the distance between the two slits on this thing. Notice that we actually don't care about how wide the slits are. What matters for this effect is how far apart the slits actually are in here. How wide the slits are just determines how bright they're going to be, but that's not what the problem's after. We're looking at the distance between the slits, so don't fall for that trap. Theta in this case, although I didn't draw it, represents the angle from the slits to the screen. So whatever angle you're traveling at to get to that bright or dark spot, that's what they mean by theta on here. M in this formula represents which maximum we're talking about from the middle. If it's the first maximum that you see, it's m equals 1. If it's the second maximum, then it's m equals 2, and so on. So this one's talking about the third order maximum, so we put in m equals 3. By the way, if you want to find the dark spots, just put the number in between. So for the first dark spot, m equals 0.5, and so on. And theta, of course, represents the wavelength of the light. Now that I've explained all that, watch the next video and I'll tell you how to actually work the problem out.